All right, you guys, so we're looking at note section 3.5, and this is solving quadratic equations. And so we're going to be finding the answers, and we're calling this the pursuit of laziness, and that's because we want to do the easiest method to solve any of the equations. When we solve, the solutions are the x-intercepts, and they always follow that pattern x, comma 0. And remember, there should be 2 because the degree is 2. So we should have x1 and then x2 comma 0. And there are 3 ways that we can solve quadratic equations: factoring, the quadratic formula, and completing the square. So when we look at factoring, the steps are pretty basic. We factor. I usually use the t-table with b and ac. Then you're going to set each factor. Remember, the x-intercepts have a y value of 0, so you set each factor equal to 0, and then, based on the zero product property, you'll have 2 different answers, and of course, then you solve. So let's take a look at that. In this case, I'm looking, I see a 3 and a 12. I start to think there's a GCF of 3, but that doesn't work for 16. So I make my table b and then a times c. It's going to be negative 16 is the b value. A is 3, c is 12, so that's going to be negative 36. And I usually just go down the line. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and of course 6 and 6. Now I for sure won't miss any, and I always usually go 1, 2, 3, 4, 5. 5 wasn't a factor. Now because it's negative, I need one of them to be a negative factor. And then because the b value is negative, I want the larger factor to be negative so that when I add them, the answer is negative. So negative 36 and 1, that would be negative 35. Negative 18 and 2, that would be negative 16. So these are the values that I use to split the middle term. 3x squared plus 2x minus 18x minus 12. And then I'm going to keep going. You should try to finish this on your own. So I cut out the GCF. Remember, we take the x out. 3x plus 2. It starts with a negative, so we have to take out a negative. And I'm going to take out 6 because that will go into 18 and 12. So that'll change the sign to 3x. I'll change the sign to plus 2. These are supposed to match, so I'm on the right track. So I have x minus 6 equals 0. I'm kind of skipping that step. And then I say 3x plus 2 is equal to 0. And then I solve for x. On the first one, I get 6 comma 0. Oh, I'm out of space, so I'm going to write them right here. 6 comma 0. And then on the other one, I have 2 steps to do. I'll take away 2, and that gives me 3x is equal to negative 2. So then I divide by 3, and I have negative 2/3 is the x value. And so that's the fastest way when it factors, usually. The quadratic formula, as you know, you find a, b, and c. They're equal to numbers. We're going to plug them into the formula. What's that formula again? It's x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And then 3 would be simplified with a calculator. So in this case, I've got a is equal to 3, the number 3, b is equal to the positive 2, and c is equal to 7. So when I go to fill it in, it's negative 2, the opposite sign of b, plus or minus every time. And then I always will square b. So 2 squared is 4, minus 4, and then use parentheses here, times 3 times 7, divided by 2a divided by 6. So then in here I've got 4 minus, so I always do this side work, and then I'd multiply these together. 4 times 3 is 12. 12 times 8 is 84. So 4 minus 84, I get negative 80. And previously we would have said, oh, no real solutions. But we've learned about imaginary numbers, so we're going to keep going. So I'm going to say negative 2 plus or minus the square root of negative 80. We're thinking of this all divided by 6. So negative 80 is going to be 16 times 5. So remember, we want to simplify our radical by taking out any square factors. I am a lot better at this than maybe an Algebra 2 student is because I teach Algebra 2. So I already have a lot of the good ones memorized, like 16 into 80, 16 times 3 for 48, some of those really good ones. So I simplify each of these, but then don't forget, I also have the negative 1. And in case you forgot, the square root of negative 1 is equal to the letter I. The square root of 5 doesn't simplify, but the square root of 16 is going to simplify. So I'm going to write it as negative 2 plus or minus square root of 16, 4. Then we put the letter I, and then we have the rad 5. All divided by 6. So man, oh man, now I have to simplify. So remember, I'm going to divide all 3 parts by 2. So that's dividing 2 and 4. So the better way to write it is like this. I'm putting the 6 here, and I'm putting the 6 here. So the 2 and the 6, that's going to make 1/3, plus or minus. The 4 and the 6, that's going to make 2/3, but still I rad 5. And then this is going to be our final answer because we can't write a decimal altogether because it's this imaginary number. So sometimes you think, oh, the quadratic formula is going to be so easy. I use the quadratic formula when I know it doesn't factor. Because this was the example to see quadratic formula, of course I just started with that. But typically I'm going to erase this. So if you need to, pause and write it down. I would check to see if it factors. Okay, so that would mean I would quickly make that t-chart. I would have 21, and then I would have 2. But 21 is positive, so there's no negative factors in it. So that would just be 1 and 21, 7 and 3. And neither of those factors are going to add to 2. So that's how we know it doesn't factor, and we want to use the quadratic formula. Now completing the square is going to be a little bit of different work. So to complete the square, we usually check to see if it has an a value of 1 and that the b value is even. And so this one does confirm and have those characteristics, but we don't want that negative 3 there. We're going to want a special number there. So to complete the square, we're going to first subtract the old c. I call that. Then we're going to add in the new c. And that's going to be, remember to get that, we have this formula. So we take the b value, we divide it by 2, and then we square it. And this is equal to the new c. We add this new c to both sides. So then step 3, we factor the perfect, oh, I forgot the e, perfect square side. And we're going to factor it to x plus b over 2 parentheses squared. Okay, next we take the square root of both sides. And don't forget the plus and minus on the number so that we can get 2 answers. And then finally, solve for x. So we subtract the old c, we add in the new c, which we get using that special formula, b divided by 2 squared. We're going to add that to both sides of the equal sign so that it's still balanced. That's going to give us the ability to factor one side, and then once it's factored, to having a square on the outside of parentheses, we can take the square root to undo the square power. And then that will give us 2 answers. So let's do it. We're going to subtract the old c. So in this case, I actually have to add it. I should have said the word move. Move the old c. That way you would know to use plus or minus. Then I've got x squared minus 6x plus something special is equal to 3 plus something special. So to find that something special, it's b, so negative 6 divided by 2 squared. So negative 6 divided by 2, negative 3. Negative 3 squared is equal to 9. So I add 9 to both sides. So now I can factor this to x minus b divided by 2. So that'd be 6 divided by 2, which is 3. Squared is equal to 12. Okay, so this is like the big idea. So it's that same value in there, and there was this value that I added here. Super, super fun. And now I take the square root of both sides. The square root cancels out the square power. I have x minus 3 is equal to, this is where I put the plus and minus to get 2 answers. Plus and minus square root of 12. But I don't really want to write square root of 12. Remember, we're going to simplify that. That's equal to 4 times 3. So the square root of 4, that's going to be 2 rad 3. And now to solve for x, I just add the 3 so that it's by itself. And I'm going to add it to the front of this expression. I have x is equal to 3 plus or minus 2 rad 3. And then I could write comma 0 so that these are x-intercepts. And I probably should have done that with my imaginary numbers for the quadratic formula too. So completing the square requires that you memorize a formula. It's kind of similar to that h. H is equal to negative b over 2a. It's kind of the same. So let's get some practice in. You want to decide which one to use. Completing the square, factoring, or quadratic formula. If you test and it can factor, definitely factor. So these are our strategies. If a is 1 and b is even, you want to complete the square. Just adding in another number, and you take the square root. Okay, if you can easily find the factors, factor. And if you can't, then use the quadratic formula. Just be careful. Students make mistakes with PEMDAS on quadratic formula. So first I want to go through and just decide which one's the best method for 1 through 9, looking at them. And I'm going to put little letters. So for number 1, I noticed that A is number 1, but B is not even. So I'm going to try factoring. And factoring, I think, is going to work. Because I'm going to have 18 and 9. And I think, oh yeah, 6 and 3. So that one came to me right away. For number 2, A is 1 and B is even, so I'm going to use completing the square. Number 3, ooh, doesn't look factorable right off the bat. Let me see, negative 40 and positive 1. No, I'm going to use the quadratic formula. Number 4, it might be factorable. 6 times 15, though, I don't know off the top of my head. 60 is 15 times 4. So 60 plus 30, 90. Oh yeah, this does factor. 90 and 1, it's going to be 9 and 10. It looks like the 9 will be negative. X squared plus 2x minus 5, let's use completing this square. 2x plus 3 minus 5, I think that will factor. Let me see. I have negative 10 and positive 3. And 10 is 5 times 2. So if the 5 is positive, the 2 is negative, yeah, that's going to factor. I forgot to put the F's. And then looking here, 3 and 2 and 1, I don't think that's going to factor because it's all positive. Because I want a 2 here and a 3 here. No, so I'm going to use quadratic formula because there's an A value. With number 8, I think I'm just going to complete the square. And then number 9, I will probably want to use a quadratic formula. Let's test. I've got negative 24 and 6. So it hasn't come to me right away. I've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And I don't see any of those adding to